I'd like to now invite up to the stage Professor Somea from University of Tokyo, and on link from Sweden we have Professor Magnus Berggren from Linköping University. Will be very exciting to hear your project presentation also. Please.
So thank you very much. Good afternoon or good morning. My name is Takao Somea from University of Tokyo, and Swedish team is led by Professor Magnus Berggren, Linköping University. So could you show my presentation slide at screen, please? Yes, next one, please. So global aging is widely perceived as one of the most significant risks to global prosperities. In order to improve the quality of life for elderly people, what we should do? The first solution is home health care, in which people are responsible for their own health, as well as their family members. The second solution is to seize the gift of longevity. If elderly people can continue to remain active participants in society, the burden of healthcare can be reduced. At the same time, their rich experiences can be shared by young generation. Now, our vision is quality of life for elderly people will be enhanced by continuously monitoring health conditions. So to achieve our goal, we need to foster age-friendly accessibility to information. When IT technology is utilized to support and to maintain health and support independence, it should be friendly for elderly who is the user. How wonderful it is if everyone can, we can monitor health condition anywhere, anytime, everywhere. So towards the realization of data-driven society for elderly, we will enhance reliability and conformability of wearables. So we will clarify the required specification and a business model to promote social implementation. So this is quite exciting. So each country may have different culture, lifestyles, and measured to evaluate their values. So although enabling technology might be very similar, but we need the customization and to establish the business model that may well fit with the value of in each country. So to achieve our goal, so we formed the Japanese-Swedish collaboration team led by University of Tokyo and Linköping University with many industrial partners. So now I want to show you our enabling technology. So this is the closed type motion capturing system where 7 accelerometers are embedded on the surface of sportswear. So we don't need the markers or complicated camera setting. Just wear this clothes, having the multiple sensors, start monitoring people's motion very accurately. Just you need to wear the clothes. So this smart wears are developed by Zenoma, which is the startup company from the University of Tokyo. So complicated some camera setting may be allowed at the very specific place, but because we don't need the camera setting, so we can start monitoring the athlete motion everywhere, anytime, even in the golf or during the running. So now we want to discuss the technology in detail. So one of the amazing things of this technology is accuracy. So now we want to monitor the minimum toe clearances. Just we start monitoring people's motion, from which we accurately evaluate the minimum toe clearance, which is always very important to watch the walking style of elderly. From our estimation, we achieve the accuracy of minimum toe clearance to be 2 centimeters, which is sufficient to get the good feedback. So now we could go to the field trial. And this is the public demo. And to test the feasibility, we have evaluated the walking patterns of 100 adults using our e-skin capturing system. And 10-meter walk is sufficient to evaluate the individual walking characteristics, from which we may know the some problems of walking, and then give the some feedback to individual users. So now you see the movie of public trial. So we want to now use this wearable tech to improve the quality for the elderly people. So we have now 2 different use. One is the clinical use, and the other one is home use. Both of them have different requirement and specification. So in clinical use, we need the quantitative and objective assessment. Lack of those 2 assessments leads to the bias evaluation or absence of standardized record of improving during the patient rehabilitation program. And in home use, they have to wear this kind of clothes for a longer period of time. And then comfortable wearing is quite important. Now, we make the customized pants for the elderly that can be used in clinical use. And another one is e-skin for home use. For clinical use, the easy to put on by caregivers are very important. And for that purpose, so we can now make the this kind of arrangement so that the patient can wear this one with the support of caregivers. And then for clinical use requires the more quantitative analysis, and then accuracy might be the key. In sharp contrast, the home care use doesn't require such kind of accuracy. However, the patient have to wear this wear by themselves, and much easier way to get this clothes is needed. And another important thing is comfortability. So because they have to wear for the longer period of time. Now, we want to show you the how it works. So now, person with spinal cord injury volunteers to use our first system prototype at home. And then this kind of motion can be monitored remotely, and a clinician watch the walking patterns remotely. So finally, so this is a futuristic system for remote rehabilitation. So elderly people wear our pants, and then walking patterns can be monitored remotely by clinician in hospital or daycares. And we are planning to increase the sample size, include various patient population that includes the spinal cord injury and stroke and Parkinson's disease, and try to establish the better service. Now, the rest of our presentation will be given by Professor Magnus Berggren. So Magnus, please.
Konnichiwa, everyone. Thank you very much for this introduction, Takao. I will continue with the part from on the Swedish side. Professor Someja presented the motion patterns upon walking, but in many cases also elderly become also suffering from vasculatory or respiratory disorders, and that in many cases leads to edema, basically that you have an accumulation of water in the legs. This is a condition that needs to be monitored. It needs to be maintained within a certain boundary conditions, otherwise you have to enter into hospitalization. It turns out that this needs to be monitored as it stands today by nurses or doctors basically visiting the patient or the elderly people. And we have identified here in Sweden people living on the remote countryside, and in Japan it's of course more of the metropolitan area. But there are similar problems. It's hard for doctors and nurses to travel in both locations. And we have focused very much on edema, this accumulation of water, and by doing that also using the wearables sensors that Professor Someja just reported. And the prime target is to use strain sensors that can monitor the level of swollenness in the legs. The next slide, please.
Next slide, please.
So on our side, we have developed a intra-body network technology. You can start the video if it works by clicking. Yeah, so we have sensors on the body, recording and monitoring sensor parameters. Above a certain threshold, it can then communicate this to devices that release or that call upon attention from the healthcare system. And this is a technology that is supposed to be connected to the cloud for further assistance or triggering alarm events or whatever. The next slide, please. And we have applied this technology into many disorders and healthcare settings. So this body you see here carries small sensor patches on the hand, on the chest, and also on the neck. These can communicate in between each other using low power protocols, but they can also communicate to a unit sitting, in this case, on the right side arm here. This unit can then communicate to a portable device using a Bluetooth protocol primarily, and then further on to the cloud where you have decision making supported by AI protocols. So the idea here is to apply this technology to support stockings, where we put sensors on the stocking to record the level of swollenness. Then we can then communicate this data to the healthcare provider, which in this case is Qviva. The stocking materials is provided by the companies Tricobi and Medisox, and we have had a nice collaboration with them over the entire product. Next slide, please. So specifically, these strain sensors here is marked as yellow straps. They are located, in this case, on 2 positions. These have been developed by the Japanese side, and we have then integrated those into our electronic system that is basically integrated into these support stockings. The level of swelling is then monitored by elongating these capacitors, and then you are changing the physical parameters of this device. And when you change the physical dimensions of this device, the electrical characteristics changes. In this case, it's the capacitance, which is an electronic parameter of this device. And yes, you can see down to the bottom left, you have the relaxed state, and when you stretch and you introduce a higher degree of swollen level, they turn stretched, and then you loosen down, and you can see that you can continuously all the time monitoring this, and this can then be automatically transferred to communication unit using Bluetooth protocol, and then further on for remote monitoring by the healthcare system. And as we state here, we have put those sensors at the ankle, upper calf level to monitor the levels. And you can, of course, think of having dozens of these sensors all over the sock, but in order to make the initial test simple, we have decided to go for 2 specific sensors. The next slide, please. And then, of course, it's important to monitor these level of swelling in the correct way. The application of the specific sensor has turned out to be very important. The location has been moved around a little bit. And then, of course, also connectivity. We need to charge this. There has been quite amount of work also in developing the charging, electrical charging of this, so they can be used in a remote setting. And also the digital and electronic part has been a great part of recent development and success. The capacitance voltage converter at the bottom has been another very important part. And then the next slide, please. Yeah, so one of the great achievements also recently has been to transfer this into a Bluetooth protocol that is the low energy to extend the battery lifetime. The goal is, of course, to have something that goes for 24 hours or even longer. That has turned out to be an important asset in order not to reach for connectivity and then to some extent paralyze the elderly person. So in summary, we have then utilized the communication, the Internet of Things technology platform devoted for both sensing and actuation in healthcare, combined and with all the great achievements conducted on the Japanese side and guided by Professor Someya and University of Tokyo. And we have now complete system that we are now entering after New Year to apply to a patient settings on a remote island of Sweden, where there is a particular challenge for the healthcare system to reach out to patients. And this is connected to Borgholm on Öland, the island outside the Swedish mainland. And this has been coordinated together with one of our industrial partners, being Cuviva, that is an e-health provider here in Sweden. Yeah, so by that, I'd like to thank you very much for your attention.